For millions of years, the skies of Earth were silent. No feathers, no wings, no birds cutting through the air. Only reptiles ruled the land, powerful and unstoppable. But deep within the forests of the Jurassic period, evolution was quietly preparing its greatest transformation. Scales would become feathers, arms would stretch into wings, and the first sparks of flight would ignite. Today, we journey back 150 million years to uncover the ancient creatures that reveal how birds rose from dinosaurs. These are the first flyers of Earth, the species whose bodies preserved the story of evolution itself. So let us begin with our today's topic. Archaeopteryx is one of the most extraordinary creatures ever discovered, often called the missing link, because it connects reptiles directly to modern birds. Living around 150 million years ago, Archaeopteryx possessed a fascinating blend of characteristics. Its body still carried the unmistakable marks of its reptilian ancestry. Sharp, needle-like teeth inside its mouth, a long, bony tail similar to small dinosaurs, and 3 clawed fingers on its wings that it could use to climb trees. Its skull, limb structure, and even the arrangement of its bones closely resembled small predatory dinosaurs like Velociraptor. And yet, despite these reptile traits, its body was also covered in beautifully preserved feathers, the same kind seen in modern birds. These feathers were long, symmetrical, and perfectly suited for gliding. Its lightweight bones and well-formed wings show that Archaeopteryx was capable of short bursts of flight or gliding between trees. This combination makes it unique. It is the earliest known creature that is both dinosaur and bird. At the same time, Archaeopteryx proves, more clearly than anything else, that birds evolved directly from feathered dinosaurs, marking the very moment evolution began. Microraptor is one of the most visually striking prehistoric animals ever found, living about 120 million years ago in the forests of China. What makes it extraordinary is that it had 4 wings, long feathers on both its arms and legs. When scientists discovered this, it shocked the world, revealing that early evolution experimented with many versions of flight before perfecting the modern bird. Microraptor's feathers were glossy and iridescent, similar to modern crows, giving it a mysterious black sheen. Its body was small, about the size of a crow, but agile, with sharp, sickle-shaped claws allowing it to climb trees easily. Microraptor didn't flap like modern birds. Instead, it glided silently from branch to branch like a flying squirrel, using its 4 wings to steer and control its speed. Its uniqueness lies in its unusual body plan. No modern animal has 4 wings. Microraptor represents a crucial evolutionary experiment, proving that the path to flight was not straightforward. Nature tried many designs, and Microraptor shows one of the most beautiful and unusual attempts. Hesperornis is one of the most unusual ancient birds because it completely abandoned flight and adapted itself to life in the water. Living around 80 million years ago, this bird grew nearly the size of a modern penguin, but carried a surprising trait. It still had sharp teeth inside its beak. These teeth helped it catch slippery fish with ease as it propelled itself through prehistoric seas. Its wings were almost useless, reduced to tiny stubs, but its legs were powerful, positioned far back on its body like modern loons. This gave Hesperornis incredible underwater efficiency, but made it awkward on land. Its long, streamlined body made it a fast and agile swimmer, perfectly evolved for hunting in ancient oceans. The uniqueness of Hesperornis comes from its evolutionary reversal. It shows that even though early birds were learning to fly, some species gave up flight entirely to dominate new environments. Like the oceans, Hesperornis proves that evolution always favors survival, whether in the air or deep beneath the waves. Ichthyornis lived about 95 million years ago and is one of the closest prehistoric birds to modern species in terms of flight ability. It soared like a modern seagull, with long, narrow wings designed for fast, efficient flight over oceans. But despite its modern flying skills, Ichthyornis still carried one ancient and surprising feature: teeth. Its beak was sharp and pointed at the end, but the back of the jaws still held tiny reptile-like teeth. This made it incredibly effective at catching fish and gripping prey. Ichthyornis likely spent much of its life flying over coastlines, diving into the water, and returning to rocky cliffs to rest, much like seabirds today. Its uniqueness lies in its mixture of modern and ancient traits. The flight of a modern bird fused with the jaws of its dinosaur ancestors. Ichthyornis is a perfect example of evolution in transition, showing how birds gradually shed their reptilian features while becoming skilled flyers of the sky. Together, these 5 extraordinary creatures reveal the long and complex journey from reptiles to birds. Archaeopteryx shows the very first steps toward flight. Microraptor displays evolution's experimental creativity. Confuciusornis introduces the modern beak. Hesperornis proves that birds could conquer oceans as well as air. And Ichthyornis demonstrates the final stages of transformation into the birds we know today. Their bodies preserve millions of years of change, each fossil a chapter in the story of evolution's greatest achievement, the birth of flight. From forests to oceans, from claws to feathers, from teeth to beaks, the rise of birds stands as one of the most beautiful transformations in Earth's history. If you want more videos like this, then subscribe to AST Knowledge Films.